Hello, welcome to Tech with Praise James. In this channel, I explain artificial intelligence and machine learning jargon through storytelling. Today, we're going to talk about three core pillars in machine learning that you've probably come across: supervised learning, unsupervised learning, and self-supervised learning. I'm going to explain what each of them means and what differentiates one from the other. So, call me best friend. Supervised learning is a type of machine learning technique where we train a model with labeled data. A labeled data is raw data that has been assigned one or two labels to give it context or meaning. So let's say you have an image of a dog and then you attach the name dog to the image, so that becomes a labeled data. So supervised learning is training a model with data that is labeled, giving it the context or the meaning around that image or whatever data set you're using to train the model. So with time, the model will learn to associate features with that particular label. So when it sees the picture of a dog, then it would know that this is a dog. It's basically like giving a model flashcards. You're giving it expo, like I'm telling you the answer. So when I ask you again, don't go and forget what the answer is. So that's essentially what you're doing with supervised learning. So we see supervised learning in image classification, in spam detection for emails. Essentially, from the name supervised, is basically supervising the model by giving it label data, giving it context, giving it meaning, so that it's able to in the future now associate certain features with certain labels. Number two is unsupervised learning. Here, the model is not giving any label data, okay? It's thrown into the world and it's saying, you know what, learn on your own. So now the model has to learn to find structure and find patterns, figure out that, okay, this group of images, they seem similar, so maybe this is how it's supposed to work. Unsupervised learning has to do things on its own. It has to figure out patterns and structure and make sense of the data on its own. So it's not giving expo in Nigeria world, okay? It has to work hard by itself to be able to figure out what works and what makes sense to it. So that's why it's used in customer segmentation, to segment customers into different groups by finding patterns, maybe their buying behaviors. So the model is not giving any context in the data. Number three is self-supervised learning, and now this is like the middle, like the sweet spot between supervised learning and unsupervised learning. So here the data is still unlabeled, it's not giving context in data, right? But yet it's able to find its own signals, or you can call it labels. It's able to find its own labels. So instead of relying on human labeled data, it creates its own data. It's like, I got this, okay? I'm smart enough. Leave it for me. I got this. So the models are trained to predict other parts of their input by learning from existing parts of the same data. We use self-supervised learning when we're dealing with large amounts of data sets where using humans to label them will be time-consuming and expensive. Imagine you are dealing with millions of rows. Getting a human being to start adding context, adding labels to every single data point, it is time consuming and very expensive. You can see self-supervised learning in computer vision, okay, image processing. You can see it in GPT, the ChatGPT that I use all the time was trained with self-supervised learning methods. So to help you understand these three different types of machine learning techniques better, let's use an example. So let's say students are trying to prepare for their maths exam, and for the first student, his teacher gives him a worksheet with both questions and answers to practice. He goes home, he looks at the questions, he looks at the answers, he practices them. On the day of the exam, he's giving new questions similar to the ones that he practiced. He does very well. Kudos to him and his teacher, right? Now, let's say the second student is not giving any answers. He's only giving practice questions. He goes home and he's like, okay, looking at this question, number 1 to 5 is under geometry, number 6 to 10 is under algebra. So he's able to group the questions into different categories, and using that information, he goes on YouTube, he checks his textbook, he uses that to practice, and then on the exam day, he does well too. Now, the third student is given a worksheet of practice questions, but some of the questions are missing. He doesn't have answers. but he still have missing parts of the questions. So he has to go home and start trying to figure out the missing parts of the questions, like a puzzle. So he's like, from this question, it seems like 33 is missing here. From reading the question, he's able to guess the parts that are missing, add them together, practice, and do well on the exam day. So the supervised learning had a tutor. The unsupervised learning didn't have a tutor, but he's able to figure out that some questions are under a particular topic, and then he's able to cover those topics. The third person doesn't have answers, and he also has incomplete questions. So he reads the questions, he's able to figure out what numbers of what words are missing in the questions, and that's how he's able to practice. So that should help you understand what supervised, unsupervised, and self-supervised learning means. So let's talk about what truly differentiates these three machine learning techniques. So number one, supervised learning is powerful, okay? Giving the data context and meaning makes it powerful, but it is expensive to scale if you have to work with a large data set. Who is going to label it? The time is going to take to label it, because someone has to label all that data. Number two is unsupervised learning. Unsupervised learning doesn't need labels, so that means it's easier to scale, but it lacks precision because it has to be learning from patterns. It's not giving context. It has to figure out on its own what makes sense to it. So it is not typically used alone. It has to be complemented with other techniques. Self-supervised, I don't want to sound like I'm doing PR for self-supervised learning, but it is easier to scale like unsupervised. It also lends useful representations like supervised learning. Models like GPT and Clip, they were trained with self-supervised learning or massive amounts of unlabeled data. That brings us to the end of today's video. Supervised learning needs labels. Unsupervised learning doesn't need label. It learns from pattern and structure. Self-supervised is like, I got this, okay? I got this. So that is the difference between supervised, unsupervised, and self-supervised learning. If you learned something new, you enjoyed watching this video, please don't forget to like, share, and subscribe. You know I got you. I've been dramatic, but yeah, thank you for watching to the end.